Okay, so section 5.4 deals more with integrals. So first we're going to evaluate this integral. So first we take the antiderivative. So the antiderivative of x squared minus 3 is 1 over 3x to the third minus 3x. And then this is still within negative 2 to 3. And so when we evaluate this, we get 1/3 3 cubed minus 3 times 3 minus 1 over 3 negative 2 cubed minus 3 times negative 2. So we simplify this. So we get 3 times 3 is 9, times 3 is 27, over 3 is 9. So we end up with, over here, we have 9, minus 3 times 3 is 9, so minus 9, and then minus 2 to the third is 2, 4, 8, negative 8 over 3, so minus 8 over 3, minus 3 times negative 2, which is plus 6. So we end up with negative 10 over 3, and that's the area under the curve. The second problem we have deals with displacement and distance traveled. So displacement is what the area under the curve is, or an integral. And so we don't really need to worry about anything. It's the distance from the origin point to the end point. So the area under the curve. So find the antiderivative. So we have 5 over 2t squared minus 9t from 0 to 3, 45 over 2 minus 27. We get negative 9 over 2 meters. So that's the distance from the start point to the end point. Distance traveled, however, is the total distance traveled. So we need to find when it's negative, like when it crosses over the x-axis, so that way we know when it's negative and when it's positive. So because in a normal integral, what it does is it automatically subtracts the area that is under the x-axis, but we don't want that. We still want the area under the x-axis because that's still distance traveled. So we need all of that. So what we're going to do is take our distance, or our original equation, 5t minus 9, set that equal to 0. So we get 5t equals 9, t equals 9 over 5. So this is our critical point. So what we're going to do is split our integral and use that because one of them is going to end up being negative. And we don't want it to be negative. So we have integral of 0 to 9 over 5. 9 minus 5 t dt plus integral from 9 over 5 to, what was our original point? 3. 5t minus 9 dt. So we get 9t minus 5 over 2 t squared, 0 to 9 over 5. No, this is still plus. Plus 5 over 2 t squared minus 9t from 9 over 5 to 3. So then when we plug in these numbers, we get 81 over 5 minus 5 over 2 plus 81 over 25 plus 45 over 2 minus 27 minus the quantity 5 over 2 plus 81 over 25 minus 81 over 5, and then our answer ends up being 117 over 10 meters. And so this is all the distance that we traveled, including the area under the x-axis.